Why it's not possible to live on Venus. When you look up at the night sky and see Venus shining brilliantly, you're looking at Earth's so-called sister planet. Same size, similar mass, right next door in cosmic terms. You'd think if we could colonize any planet, Venus would be high on the list, right? Wrong. Dead wrong. In fact, Venus is quite literally the closest thing to hell that exists in our solar system. And I'm not being dramatic here. We're talking about a world so hostile, so unimaginably extreme, that the longest any human-made spacecraft has ever survived on its surface is just 127 minutes. Most didn't even last an hour. Today, we're diving deep into why Venus isn't just uninhabitable, it's practically impossible to even visit. We'll explore the crushing pressures, the melting temperatures, the toxic atmosphere, and the bizarre phenomena that make this planet more hostile than the surface of the Sun in some ways. So buckle up, because we're about to visit the planet that eats spacecraft for breakfast. Section 1. The Runaway Greenhouse from Hell. Let's start with the obvious. Temperature. You've probably heard that Venus is hot, but hot doesn't begin to cover it. The average surface temperature on Venus is 464 degrees Celsius. That's 867 degrees Fahrenheit. To put that in perspective, that's hot enough to melt lead, zinc, and tin. Your spacecraft? If it's made of conventional materials, it starts softening and failing within minutes. But here's what makes it truly insane. This temperature is constant. Day or night, equator or poles, it doesn't matter. Venus is the same hellish temperature everywhere, all the time. Unlike Earth, where night brings cooling and the poles are freezing, Venus maintains this inferno globally. Why? Welcome to the runaway greenhouse effect in action. Venus's atmosphere is 96.5% carbon dioxide, the same gas we're worried about on Earth, but at concentrations we can barely imagine. This thick CO2 blanket creates an atmospheric greenhouse so effective that heat can't escape. Solar radiation comes in, gets absorbed by the surface, and then gets trapped by all that carbon dioxide. It's like wrapping an entire planet in the universe's most effective insulation. But it wasn't always this way. Scientists believe that billions of years ago, Venus might have had oceans, maybe even a climate somewhat similar to early Earth. But something went catastrophically wrong. Without a magnetic field to protect it, solar radiation began stripping away hydrogen from water vapor in the upper atmosphere. The oceans evaporated. Water vapor, itself a greenhouse gas, trapped more heat. This caused more evaporation, which trapped more heat, in a vicious cycle that ultimately turned the planet into the oven we see today. All that water? Gone. What's left is just a trace amount of water vapor, about 20 parts per million. The lesson? Greenhouse effects can spiral out of control, and once they do, there's no going back. Section 2. The crushing weight of Venus. Now, temperature is only part of the nightmare. Let's talk about pressure. Standing on the surface of Venus would feel like being 900 meters underwater on Earth. That's nearly 3,000 feet down in the ocean. The atmospheric pressure on Venus is 92 times greater than Earth's at sea level. That's 92 bars, or about 1,350 pounds per square inch, crushing down on every inch of your body. Imagine a person standing on your chest. Now, imagine 92 people standing on your chest. That's what Venus does to everything that lands on it. This pressure doesn't just make things uncomfortable, it fundamentally changes how materials behave. Metals become more malleable, seals fail, electronic components get crushed. Even the air itself becomes so dense that it behaves almost like a fluid. The atmospheric density near the surface is about 65 kilograms per cubic meter. That's roughly 6.5% the density of water. You could almost swim through Venus's lower atmosphere if you weren't being simultaneously crushed and cooked. For spacecraft engineers, this presents an almost impossible challenge. You need to build something that can withstand the pressure of the deep ocean while also resisting temperatures that would melt your submarine. The materials that work well at high pressure often can't handle the heat. The materials that resist heat often can't handle the pressure. And even if you find something that can do both, you've got one more problem. Section 3. The toxic atmosphere that eats metal. Let's talk about what you'd actually be breathing on Venus if you could somehow survive long enough to breathe. The atmosphere is primarily carbon dioxide, which would suffocate you, but that's the least of your concerns. What makes Venus's atmosphere truly alien is what's floating in it. Clouds of sulfuric acid. Between 50 and 70 kilometers above the surface, Venus has a permanent layer of sulfuric acid clouds. These aren't just mildly acidic. We're talking about concentrated sulfuric acid droplets that would eat through most materials. This is the same acid used in car batteries, the stuff that can dissolve flesh and corrode metal. These acid clouds are created by a chemical reaction in the atmosphere. Sulfur dioxide from volcanic activity reacts with water vapor to form sulfuric acid. The result is a planet-wide cloud deck that completely obscures the surface from view. When we look at Venus through a telescope, we're not seeing the planet's surface. We're seeing the top of these acid clouds. But wait, there's more. The atmosphere also contains trace amounts of hydrogen chloride and hydrogen fluoride. These are incredibly corrosive gases that attack electronics, break down seals, and corrode virtually any exposed surface. It's like Venus specifically engineered its atmosphere to destroy anything we might try to send there. And here's a fun fact. It rains on Venus. Sort of. The sulfuric acid does fall from the clouds, but it's so hot in the lower atmosphere that the acid rain evaporates before it reaches the surface. So you've got acid rain that never touches the ground. It just cycles endlessly in the atmosphere, waiting to corrode anything flying through it. For spacecraft, this means your vessel needs to be not only heat resistant and pressure resistant, but also acid proof. Every seal, every joint, every electronic component needs to be protected from an atmosphere that is actively trying to destroy it. Section 4. The Soviet Venera missions. Triumph and tragedy. Now, you might be thinking, if Venus is so impossible, how do we know all this? The answer is, the Soviet Union decided to find out the hard way. Between 1961 and 1984, the Soviet space program launched a series of probes called the Venera missions, Russian for Venus. These missions are legendary in the history of space exploration, not just for what they achieved, but for what they had to endure to achieve it. The early Venera missions were disasters. Venera 1 lost contact before arrival. Venera 2 failed upon arrival. Venera 3 crashed without sending data. But the Soviets kept trying, learning from each failure. Venera 4, launched in 1967, was the first to send back data from Venus's atmosphere. But it was crushed by the pressure before reaching the surface. The Soviets had underestimated just how extreme Venus was. They thought the pressure might be around 20 bars. They were off by a factor of nearly 5. After several more attempts and design iterations, Venera 7 became the first spacecraft to successfully land on another planet and transmit data back, touching down on December 15th, 1970. It survived for 23 minutes. But the real triumphs came later. Venera 9 and 10 sent back the first photographs from the surface of another planet in 1975. The images showed a rocky, desolate landscape bathed in orange light. Then came Venera 13 and 14 in 1982, which hold the survival records, 127 minutes and 57 minutes respectively. These hardy probes were engineered specifically for Venus, heavily insulated, pressure-resistant, with internal cooling systems and protective coatings. They were essentially deep-sea submarines designed to survive on a different planet. Venera 13 managed to take colour photographs, drill into the surface, analyse soil samples, and even record sound. The first and only audio recording ever made on another planet. The images it sent back show flat rocks, some volcanic, scattered across an orange-tinted landscape under a thick, hazy sky. But even these incredibly over-engineered Soviet spacecraft couldn't last more than 2 hours. The heat eventually penetrated their insulation. The pressure slowly crushed their hulls. The corrosive atmosphere ate away at their seals. One by one, their systems failed, and they fell silent. No spacecraft has landed on Venus since 1984. Not because we don't want to, but because there hasn't been a compelling enough scientific reason to justify the enormous expense of building a spacecraft that will die within hours. Section 5. Why human colonization is a fantasy. So, after everything we've discussed, let's address the big question. Could humans ever live on Venus? The surface? Absolutely not. Not now, not ever. Not with any technology we can currently envision. Think about what you'd need. A habitat that can withstand 92 atmospheres of pressure while resisting temperatures hot enough to melt lead, all while being impervious to sulfuric acid and corrosive gases. You'd need power generation that works in those conditions. Life support that can't fail for even a second. And you'd need to get all that equipment there and keep it functioning indefinitely. Even if we could build such a habitat, and that's a massive if, why would we? There's nothing on Venus's surface worth the risk. No water to extract, no minerals we couldn't get elsewhere more easily, no scientific data that couldn't be gathered by heavily shielded probes. But here's where it gets interesting. While the surface is impossible, there's one place on Venus that's actually almost pleasant. About 50 kilometers up in Venus's atmosphere, there's a zone where the temperature is around 60 degrees Celsius and the pressure is about 1 atmosphere, roughly the same as Earth's surface. You could theoretically build a floating habitat at this altitude using regular Earth materials. In fact, breathable air, which is mostly nitrogen and oxygen, would actually be a lifting gas on Venus. So an inflatable habitat filled with air we could breathe would naturally float at this altitude. This concept, called a cloud city or floating colony, is actually one of the more scientifically plausible ideas for human presence in the inner solar system beyond Earth. You'd still have to deal with the sulfuric acid clouds and the corrosive atmosphere, but at least you wouldn't melt or be crushed. There's just one tiny problem. You'd be living in a floating balloon 50 kilometers above a surface hot enough to destroy any probe we've ever built, with no solid ground anywhere on the entire planet. One breach, one failure in your floating system, and you'd descend into hell itself. There's no emergency landing, no backup plan, no rescue mission possible. So while floating colonies on Venus are theoretically possible, the psychological and practical challenges make them extremely unlikely. We'd be far better off colonizing Mars, building habitats on the Moon, or constructing space stations, all of which offer solid ground, escape routes, and far less hostile environments. Venus is a stark reminder that not every planet is meant for us. It's a cautionary tale written across our solar system, showing us what happens when a greenhouse effect spirals out of control, when atmospheres become prisons rather than protections. The fact that our robotic explorers have survived there for mere minutes speaks volumes about just how hostile this world is. Venus doesn't just kill spacecraft, it obliterates them, melts them, crushes them, and corrodes them, often simultaneously. So the next time someone talks about terraforming Venus or building colonies there, remember, we can't even keep a heavily armoured, specially designed probe alive for 3 hours. The idea of building a permanent human settlement? That's not just difficult, it's fantasy. Venus is beautiful from a distance, shining bright in our evening sky. But up close, it's a planetary hell that reminds us that Earth, with all its problems, is precious beyond measure. Because there are worse places in the universe than Earth. Much, much worse. If you found this deep dive into Venus fascinating, make sure to hit that subscribe button for more space content. What planet should we explore next? Let me know in the comments below. And remember, stay curious, stay skeptical, and for the love of all that's holy, stay off Venus.